Buenos Inloc Zambales. Good day to our dear learners from grade 10. This is Teacher Kurt Cesar L. de Padua of Bamban National High School, and I will be your teacher facilitator for today. Before we start our lesson, I would like to acknowledge our Department of Education, Division of Zambales, especially the writer of our self-learning module in science, Teacher Joy A. Guchapin. Learners, please prepare your notebook and pen to take down notes all important ideas from the lesson. Find a comfortable place where you can listen and study properly. Welcome to Science 10. This is an exciting journey to learn on behavior of gases. We will now be entering the week 1 of the 4th quarter of this school year. Are you ready, learners? This module was designed and written with you in mind. It is here to help you master the behavior of gases. The scope of this module permits it to be used in many different learning situations. The language used recognizes the diverse vocabulary level of students. The lessons are arranged to follow the standard sequence of the course, but the order in which you read them can be changed to correspond with the textbook you are now using. The module is divided into 2 lessons, namely, describing gases, the gas laws. At the end of the lesson, you will be able to first, identify the different properties of gases. 2. Explain the kinetic molecular theory of gases. And 3. Investigate the relationship between volume and pressure at a constant temperature of a gas, volume and temperature at a constant pressure of a gas, and explain the relationship of volume, pressure, and temperature using the kinetic molecular theory. Let's start with describing of gases. There are 3 states of matter, namely solids, liquids, and gases. All the states of matter are different in their properties based on the arrangement of their particles. Solid particles are tightly packed, usually in a regular pattern. Liquid particles are close together with no regular arrangement, while gas particles are well separated with no regular arrangement. For you to understand clearly the properties of gases, I prepared a video activity that I performed earlier. Learners, get your pen and paper and take down notes what you observe and answer the guided questions.
Hello learners, I'm going to perform an activity entitled How Does Gas Behave? This activity will help you learners to understand the topic, which is describing gases. All you need to do is to observe and write down your observation. The materials needed are an ordinary party balloon and 1 liter empty bottle. So this is the procedure. Push an ordinary party balloon into 1 liter plastic bottle. Stretch the mouthpiece over the opening of the bottle. Blow into the balloon. Next, blow up an identical balloon outside the bottle to serve a comparison. Now, here is your guided question. Based on your observation, how big does the balloon in the soda bottle get? Number 2. How big does the balloon outside the soda bottle get? Explain the difference.
What are the properties of gases? Gas is the state of matter that has particles that are freely moving and are far from each other, which makes them highly compressible. Gases have important fundamental properties that are measurable, such as volume, pressure, temperature, and the amount of the gas or the number of moles. Let's discuss each property. Volume. Volume, which is one of the most measurable properties of gas, is denoted by the symbol V. It is the amount of space occupied by a gas sample. Its SI unit in liters, capital letter L. It can also be expressed in milliliters, or ml, cubic centimeter, or cm3, cubic meter, m3, and cubic decimeter, dm3. 1 liter is equal to 1 decimeter. 1 decimeter is equal to 1,000 ml. And 1,000 ml is equal to 1,000 cubic meter. The pressure is the next important measurable property of the gas, which is denoted by the symbol P. Pressure of the gas is the force exerted by the gas per unit area. In equation, pressure equals force divided by the area. The SI unit for pressure is Pascal, named after Blaise Pascal. This unit is equivalent to force of 1 Newton acting on 1 square meter. 1 Pascal is equal to 1 Newton over 1 cubic meter. Other unit of pressure are atmosphere, millimeter of mercury, torr, bar, kilopascal, and pounds per square inches. 1 atmosphere is equal to 760 millimeter of mercury. 760 millimeter of mercury is equal 760 torr is equal to 1.01325 bar. 1.01325 bar is equal to 101.325 kilopascal. 101.325 kilopascal is equal to 101.325 times 10 to the third power nanometer. Temperature. The temperature is denoted by the letter T. The temperature of a gas depends on its kinetic energy. Gases expand when the temperature is increased. The temperature of a gas is expressed in Fahrenheit, centigrade or Celsius, and Kelvin. Though we often use the Celsius degree when dealing with the temperature involving gases, we always express it in Kelvin temperature. The unit Kelvin was named after Lord Kelvin, a Scottish physicist, has identified the lowest attainable temperature known as absolute zero with a value of negative 270 degrees Celsius, hence the Kelvin temperature scale. To convert Celsius to Kelvin, we use the equation K equals degrees Celsius plus 273. Amount or number of moles. The amount of gas or mass is another measurable property of gas. The mass of the gas is related to its number of moles and generally expressed in kilogram or gram. Number of moles equals mass of the gas over molar mass of the gas in symbol. M equals small letter m over capital letter M. Kinetic molecular theory of gases. The properties of gases can be explained in terms of their molecular motion. The ideas about molecular motion were developed into kinetic molecular theory by Rudolf Clausius, James Maxwell, and Ludwig Boltzmann. The kinetic molecular theory of gases is a model that could help us understand the behavior of the gases. Its postulates are the following. 1. A gas consists of very small particles. The particles are in constant random and straight-line motion. The particles of a gas are separated by the distances much larger than their size. The attractive forces between particles are negligible, and the particles act independently of one another. The gas particles collide with each other and with the walls of the container in a perfectly elastic manner. After each collision, the total energy of the system is the same. The average kinetic energy of the gas particles is proportional to the absolute Kelvin temperature. As the temperature increases, the gas particles move faster. As I said a while ago, we discussed the four measurable properties of gases, such as pressure, volume, temperature, and number of moles are related to each other. If one of these variables is changed, there is a corresponding change in other variables, depending on its relationship. Gas-law equations can derive whenever one of these variables is altered. There are four main gas laws. These are Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. The combination of Boyle's law and Charles' law is also known as combined gas law, while the relationship between variables used by the four main gas laws is explained by the ideal gas law. Boyle's law. Robert Boyle, an English chemist, was the first to investigate the relationship between the pressure of a gas and its volume at a constant temperature. Based on his experiment made wherein he trapped a fixed amount of air in a J-tube and changed the pressure at a constant temperature. He found out that as the pressure increases, the volume decreases. He then concluded that the volume occupied by the fixed amount of gas is inversely proportional to its pressure at a constant temperature. Boyle's law can be expressed by a following equation, where V stands for volume, P is for pressure, and T is for temperature. Small letter n is equal to the amount of gas. To change the proportionality sign to an equal sign, the proportionality constant is introduced. For a given sample of gas under two different conditions at a constant temperature, the product of pressure and volume is constant, and it is written as follows, where P1 and V1 are the initial pressure and volume, P2 and V2 are the final pressure and volume at constant temperature and the same amount of gas. In Boyle's law, the following formulas are to be used when three variables are given and one is unknown. Kinetic molecular theory and Boyle's law. The kinetic molecular theory of gas helps us understand the inverse relationship between pressure and volume. Pressure is created when gas particles collide with the walls of the container, and every time a gas particle collides with the wall, it exerts a force on the container wall. As the average force exerted by the gas particles increases, the pressure of gas increases, thus decreasing the volume of the gas. Charles' law. French physicist Jacques Charles determined the volume-temperature relationship in gases. From his experiment on balloons, Charles observed that at constant pressure, the volume of gas increases with every increase in temperature. Also, volume decreases as temperature decreases. Charles' law states that the volume of a fixed amount of gas maintained at constant pressure is directly proportional to its absolute temperature. Charles' law can be expressed by the equation, where V1 and T1 are the initial volume and temperature, V2 and T2 are final volume and temperature at constant pressure and the same amount of gas. In Charles' law, the following formula are to be used when three variables are given and 1 is unknown. Kinetic molecular theory in Charles' law. From the kinetic molecular theory, the average kinetic energy of a gas particle is directly proportional to the temperature of a gas. The particle's average kinetic energy is related to its speed. When the temperature of the gas is increased, the particles move at the higher speed. This results in frequent collisions of the particles with the walls of the container, so the gas particles exert a greater force on the walls. Gay-Lussac's law. The person who is credited with the determination of the temperature-pressure relationship in gases at constant volume is Joseph Louis Gay-Lussac. He deduced that the pressure of the gas is directly proportional to its temperature. Gay-Lussac's law states that at constant volume, the pressure of a fixed amount of gas is directly proportional to the absolute temperature. Gay-Lussac's law can be expressed by the equation, where P1 and T1 are the initial pressure and temperature. P2 and T2 are the final pressure and temperature at a constant volume and the same amount of gas. In Gay-Lussac's law, the following formula are to be used when 3 variables are given and 1 is unknown. Combined gas law. Boyle's law and Charles' law can be combined and treated as a single law. It's called the combined gas law, which describes the pressure, volume, temperature relationship of a constant amount of gas. The pressure and volume of a gas are inversely proportional to each other, but are both directly proportional to the temperature of that gas. Translating it to mathematical equation. At constant number or mole, the equation is where P1, V1, and T1 are the initial pressure, volume, and temperature, P2, V2, and T2 are the final pressure, volume, and temperature at constant amount of gas. In Boyle's law, the following formula are to be used when 5 variables are given and 1 is unknown. Avogadro's law. When you inflate a balloon, its volume increases because you add more air molecules. If the balloon has a small hole, the air leaks out and causes the air volume to decrease. Amedeo Avogadro, an Italian chemist and physicist, formulated the Avogadro's law. In Avogadro's law, the following formula are to be used when 3 variables are given and 1 is unknown. Ideal gas law. At this point, different gas laws, Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law have been discussed. The equations represented this law may be combined to arrive at one equation that interrelates pressure, volume, temperature, and the amount of gas. This combination gives the expression called ideal gas law. The different equations that comprise the ideal equation are the following. The proportionality sign can be replaced by inequality sign by introducing a proportionality constant, or the constant R is known as the universal gas constant with a value of 0.0821 liter atmosphere mole Kelvin. In the ideal gas law, the following formulas are to be used when 3 variables are given and 1 is unknown. Now, let's proceed to the assessment. You are going to identify what's in this statement. Okay, time to reveal the answers. How is your score so far? I'm proud you did a good job. You are doing great. You will always bear in mind that there are better things than getting high scores. What is important is you learn from the mistakes and become better learner at the end. I hope you enjoyed and learned a lot about behavior of gases. Once again, this is your on-air teacher, Teacher Kurt Cesar de Padua of Bamban National High School. Serbisyong Putog Radio, DWSP 101.5 News FM. Your DepEd Radio Eskwela. Goodbye everyone and have a good day.